Hello. This video will demonstrate how to use de Moivre's theorem to raise a complex number to some exponent. And what we have to do first, as you can see, we need to first take our complex number and convert it to polar form. And once we have that in polar form, and we have our exponent n, the formula says, take your modulus and raise it to the power n, and your argument theta, multiply that by n. And then, of course, once you have this in polar form, convert back to complex. Okay? So let's do an example and let's see how it goes. So suppose I want to take negative 6 plus 2i, and I want to raise that 9th power. Okay? So the first thing I said we need to convert this to polar form. Yes, you can use your calculator, but just in case you are asked to show all of your work, I will do this by hand. Right? Remember, this is our real axis, our x-axis, and this is our imaginary axis. So, right, we're moving 6 on the left on our x-axis and 2 up. So this represents, all right, that point 6 plus 2i. Again, hopefully this will make sense how to find the absolute value of this point. Remember, absolute value, the distance from 0. Just as we've seen before, right, we're going to take the square root of a squared plus b squared, and that's going to give us the square root of 40. All right, and in your calculator, they will give you 2 square root 10, but I'm just going to leave it like that. The next thing we want to do is find our argument, our theta. And again, what you can see here, you will use the inverse tan, as you have before, of 2 over negative 6. And what's that going to be? All right, so we will take, we'll say 2 divide by negative 6. And I'm going to take the inverse tan of that. I get negative 18.43 degrees. Negative 18.43 degrees. We have seen this on many occasions, that negative 18.43 degrees, we need to convert that to a positive angle. By a simple drawing, I can see that I need to add 180 degrees. And when I do that, it looks like I'll have what? 141.57 degrees? Is that right? That looks right. Okay. Of 141.57 degrees. Again, some of you are still not in the habit of going to 2 decimal places. Again, with trig, you really should go to 4 decimal places. And since you have calculators, that should not be very difficult to do. All right? So, now that we have all of this, now we're going to apply de Moivre's theorem. And de Moivre's theorem says, take your modulus and raise it to the exponent, in this case 9. Take your argument and multiply it by the exponent, which again in our case is 9. Again, some of you have been asking, oh, is that 9.141? Again, what that tells me is you're not really paying attention to the formula, and you guys really need to think about what you're doing here. Okay? All right. And let's see. The square root of 40 to the 9th power is that huge number, 161,90861. I wish I could cut and paste that. Is there a way for me to cut and paste that? No. Okay, 161,908,616. All right. 161,908,61.6. All right. Okay. 141.57 times 9 gives me 1,274.13. Seriously, did I forget that? 1274. Okay, there we go. Okay. Again, you have a calculator. There's absolutely no reason why you should be rounding early. Okay? And so on. Again, what you're going to do, you're going to hopefully use your calculator. You're going to put this in. Again, if you want, if you don't want to have to write this number down, you can put this in your calculator. And you could even do that if you would like. And well, I have my trusty calculator here. Remember, right, so square root of 40, right arrow, raised to the 9th power, right arrow, angle sign, bracket, 9 times 141.57, close bracket, and then I'm going to do shift mode. Again, this only works if you have the Casio 991 ES Plus. All right, so shift mode, down arrow, complex. It is currently in polar form. We want to convert it to complex mode, so that means that we're going to pick 1. And when I do that, I get negative 157,00996.2 minus, all right, 395,255.8.5i. Again, crazy number? Sure. But remember, first of all, we're dealing with complex numbers. So already it's complex. And now we're raising it to the 9th power. Okay, so of course we expect a large and wacko number. Okay, so de Moivre's theorem allows us to take a complex number or a number in polar form and raise it to some exponent. We saw that on your calculator, if the exponent is 2 or 3, meaning we're squaring or cubing, then our calculator can do it. But for exponents 4, 5, and so on, the calculator, it's just too much work for it. So we have to know how to do this by hand. Our calculator can still help us, especially this part. Okay? So again, convert complex to polar. Take your modulus, raise it to that exponent. Take your argument, multiply it by that exponent, and simply simplify. All right, I hope that helps. Thanks for watching.